episode in our physics subject GRE, so 46. The black body temperature T1 and energy at power level 10. That's about when we increase 2 times O. So this is the Stephen's law. So power depends on the T to the force, proportional to T to the force at the black body radiation. This is a common sense. Okay, so you can see the proof. Probably I will present the proof in some other video in the future, but because it's too complicated to give a proof. Basically, there are some coefficients here involve some zeta function 3, which is very number theoretical function. But I like this function because it connected to the Riemann hypothesis. But this is a completely different story. Also, all you need to know is the proportional to the temperature to the force. This is the old question. You can see basically this question is very popular in the GRE physics. I promise that you have 80% chances to see it again. So the answer is E. The answer is E. Okay. Okay, and 47 is about Frank Hertz. Okay, so what's the Frank Hertz means? Common sense, right? Just ask you about Frank Hertz. Just test whether the electron can absorb just see the electron can absorb the photons and make a transition between the energy level. Okay, so first one says that electrons are always scattering elastic. Oh, this is definitely not right. Electrons are never scattering. Never means too strong, right? Electron of certain energy range can be scattered inelastic and the range loss. C. Somewhat we just keep it. Electron always lose the same energy when the same elastic loss energy. Okay. This looks somewhat too strong. Electron always lose the same energy. Why means same, right? There's no energy range there's no energy in which the energy lost by electron varies continuously. Okay, so the E is also too strong, right? It's also too strong. So I think the good choice is C. Electron of certain energy range can be scattered inelastically, and the energy lost by electron is discrete. So basically, this is what I say that there's an electron. Basically, the Frank Hertz showed that the electron can observe discrete energy and the transition from energy to energy. And for the transition in which one photon is radiated by electron in hydrogen, in which the electron wave function changes from phi 1 and phi 2 if forbidden. Okay, so this is about the hydrogen selection rule. So selection rule tells you that delta L cannot be 0. You need to remember this because this problem is also famous in subject GRE. So what is what? So the answer is D. If they are both spherical, then they have the same L equals 0, which is forbidden. So the answer is D. So 49, Hamiltonian operator in the Schrödinger equation before from the classical Hamiltonian by substituting what? The differential operator. So the answer is B. Right? You just change p squared over 2m into the p equals minus h bar partial x. Then you can get the answer. So 50, the Hall effect is used in solid state to measure what? Basically, it's the carrier of the charge sign of the carrier, right? So the answer is C, the sign of the charge carriers. This is old school question. You need to remember. This question is it's also popular. This is probably the second time I see this. Also, I think it's enough for today, and we will keep it in next day.